Make yourself comfortable. And Dr. Zheishang Li will shortly introduce the speakers and start the meeting. Give us another couple of minutes, otherwise I think we will start, and maybe we will start with Dr. Kwan Mao, and then Dr. Nan Li can join us a little bit later.
Yes. Well,
Using the
I'm
speaker.
sorry that one of our speakers has met some problem with the Zoom account. So yeah, so maybe it's better for us to start to this webinar. So good morning, good afternoon, or good evening, according to where you are. So welcome to today's webinar organized by UNESCO Chair in on Disaster Risk Reduction and Resilience Engineering. I'm Zai Shangli. I'm a research fellow working in this UNESCO Chair with Professor Dina Dayala, who is the holder of this chair. So today we are very pleased to have three speakers. Well, sorry, only two can log in. So we have Dr. Quan Mao and Dr. Fang Wei, who are going to give a very interesting presentation on disaster impacts beyond direct damage, assessing first and second order indirect economic impacts. So before today's webinar, uh, I'd like to preview our next webinars. So at the end of this month, we have another webinar given by Dr. Yu Dong from PolyU Hong Kong with the topic of tropical storm resilient system. And in next month, i.e. the 21st April, this will be a webinar given by Professor Qiu Chen Lu from UCL with the topic of resilient cities through digital coupled human nature and infrastructure system. So please be aware of our social media in the emails, so you will get the details for this webinar and the registration process. So back to today's webinar. Firstly, let me introduce our speakers. So, uh, well, we have three speakers. The first speaker would be Dr. Nan Li. Let's see if he could ultimately join us. So Dr. Nan Li is associate professor at the Department of Construction Management, School of Civil Engineering, Tsinghua University. He's also the director of the Institute of Sustainable Urbanization at Tsinghua. Dr. Li's research focuses on understanding and improving the resilience of the built environments, including buildings, infrastructure systems, and humans whose needs they serve, by extensive applications of advanced informatics and computational approaches. His research has produced over 100 academic publications, which have received over 8,000 citations. Dr. Li currently serves as the editor-in-chief of Advanced Engineering Informatics and associate editor of Journal of Management in Engineering and International Journal of Disaster Risk Reduction. Our second speaker, Dr. Chuan Mao, is an associate professor in the School of Management Science and Engineering and the Central University of Finance and Economics, where he also serves as deputy head of the department. He is a member of the Council of Urban Safety Branch of the Architectural Society of China. His research focuses on urban safety and resilience, indirect economic losses from natural hazards, urban system simulation, and post-disaster reconstruction. He has served as a PI for one project funded by the NFC of China and has participated in nearly 10 national or provincial level research programs, including the National Key Research and Development Program, the National Natural Science Foundation of China, and the Beijing Social Science Foundation. He has published over 10 academic papers. Our last speaker, Dr. Fang Wei, is an associate professor in the School of Economics and Management at the Taiyuan University of Technology. She earned her PhD from the Department of Construction Management at Tsinghua University in 2022. Her research focuses on assessing the indirect economic impacts of disasters and infrastructure disruptions, leveraging interdisciplinary methods that integrate IO and CGE models with engineering models. Dr. Wei also has led two provincial or ministerial level research projects and two industry-sponsored projects, and has contributed to several key programs, including projects from the NFC. She also serves as young editorial board member for Smart Construction Journal. So without further ado, let's start today's webinar. So I will stop sharing. Yes, so I think the first speaker will be Dr. Chuan Mao. So, Dr. Mao, please, the floor is yours.
Okay, thanks, Dodi. So today I will show my research on the micro level assessment of indirect economic losses from natural hazards. So first, I want to introduce the classification of the disaster economic losses. When a city suffered from a natural hazard, it first will have the direct losses, including the physical assets damage. And also it will suffer the deaths and injuries. And then the physical assets damage will cause the interruption of the production and the sales, cause the failures. So these failures, we call them as the business interruption, known as the first order indirect impacts. Then this failure will propagate through the supply and the demand two sides and cause the ripple effects. We also call this the second order indirect impacts. And why we should assess the direct losses and the indirect losses? Because we can support the emergency supplies appropriation and like the reconstruction, cost estimation, pre-disaster prevention, and also support the disaster relief and decision making, and also some like the insurance and anything else. In these three three classes of the economic losses, for the direct economic losses, actually there are many engineering models to assess the losses. But for the business interruption losses, it belongs to the domain of engineering and economics. There is yet no widely accepted extension method. So then I first want to research on the business interruption losses. For the ripple effects, it belongs to the domain of economics. There have many economic models to assess it, including the input-output models, CG models, econometric models. But these models are true macro level to assess the small scale areas. So I want to focus on the micro level. So how can we assess the indirect economics? So first, I want to introduce the definition. When a business suffer from natural hazards, its production, maybe all the sales, its output will reduce to zero for some time, and then he will recover to a certain reduction ratio, and then in a longer time, it will slowly recover to the pre-disaster level. So this area we call the indirect economic losses. So how to assess these areas? We should know the time. The business closure length and the total business recovery time, and also we need know the production reduction ratio during this time. It's the post-disaster output value impact mechanism for the business. The business output, or means the business interruption, are caused by many factors. First, it could suffer the physical damages like the land, building, equipment, and also some non-physical assets damage like material supply and the infrastructure supply failure and the workforce failure. And also it could be impacted by the social economic environment and also the business characteristics. But my research focuses more on the direct factors, including the land, building, equipment, infrastructure, surveys, and also the materials supply, workforce, and the final demand. So the first thing when I predicted the business interruption losses, the first step I evaluate the failure of these four factors because it belongs to the physical assets damage. So we can using some established models, engineering models to predict their damage and the recovery. And then we use these factors to predict the failure and the recovery of raw material supply and the workforce and the final demand. And finally, use all of these 7 factors to predict the business interruption losses. This study used a case study of Syria Stratton County during the Wenchuan earthquake. We conducted 3 surveys in this case study to investigate the earthquake impacts on the local business operations, including the manufacturing and the retailing businesses. And also we investigated the employee working conditions and the household-fired final demand. And finally, we collected a total of 30 valid responses from manufacturing businesses and a total of 194 responses from the retailing businesses. And then we compare the observed business interruption losses with the predicted ones to see whether our prediction is accurate. We measure the accuracy from three aspects. First, from the individual business level. Unfortunately, the individual business level business interruption losses predictions has large error ranges. This is because in this case study, we use some methods, some models to predict like equipment buildings. We use some probabilistic models. In these models, during each simulation, it will select a damage level randomly. So it results in the predict business interruption losses is a normal distribution. So that's the reason why the individual business level has so large error regions. In the second aspect, we measure the accuracy from the business group distributions. It uses cumulative distribution functions of the business interruption losses to production or sales ratios across 10,000 simulations. The results shows all errors were below 10% of the observed mean, which is third consistent with the acceptable prediction accuracy. In the third aspect, we measure the accuracy from the sector level business interruption losses. The results show the prediction errors fell within 5% of the pre-earthquake production or sales, indicating acceptable prediction accuracy. And also the results show that early recovery in the first months showed a slight underestimation, while later phases estimated slight overestimation. Probably because the difference in predicted mean business closure lengths and the business recovery times. Since we have made many assumptions and used many uncertainty prediction methods, so to measure these assumptions, the impacts of this assumption on the results, we use the sensitivity tests to evaluate their impact on the prediction results. And the results show that these assumptions did not change the accuracy. The second research, we assessed the ripple effects of the business interruption losses. In this framework, we have done three parts of work. First, we build a business network. Second, we do a simulation, focus on the supply chain adjustment. And finally, we estimate the losses. In the first part of work, when building the business network, actually it has two parts of the work. First, we build a supply-demand network with the association strength considerations. And the second, we build a competition networks accounting for the business sustainability. The second work, we do a simulation by conducting a supply network adjustment model. That's the core of our work. In this model, business behavior can be divided into the following 8 steps. The blue ones show the key points. When directly affected business shuts down, indirectly affected business will scan all business and submit applications to the alternative business in order. Once this business receiving the application, alternative business will make a decision to either accept or reject the application. And after all alternative business have made their decisions, the capacity of indirectly affected business will be recalculated. And in the third part of work, we assess the losses. The losses we set 3 contents. First is the decrease in the output value. That's the main losses. But we also consider other 2 losses. First is the increase in the procurement cost, and the second is the increase in transportation costs. Because in this model, the supply has been adjustment. They have some new supplies, so the procurement cost and the transportation cost will be increased. Unfortunately, in this study, we don't have the real data because it's very hard to collect data about the business network. So we use the Python to generate a network with 100 business based on the some assumptions. The assumptions including the distribution and the locations. And then we also test this as a distribution using like the 2 assets, whether they fits the small world or scale free. Then we set 4 simulation scenarios based on whether to consider the structural adjustment of the supply network and whether to consider the recovery of the direct impacted business. And since the following are the research results. First, we compare the scenario 1 and 2. the results show that through the adjustment of supply network, some business realized overproduction, and the loss of total output value was reduced by 5%. And by comparing scenario 3 and scenario 4, the results show that combined with the recovery of direct damaged businesses and the adjustment of supply network structure, the loss of total output value is reduced by 10%. And also, we compare the results to show how the recovery of direct effect business affects changes in the output value of other businesses. And the results show that the recovery of direct affected business also help relieve the problem of a decline in business output value after disaster. And that's all my presentation. Thanks for your listening.
Thank you very much, Dr. Kwang Mao. Very interesting presentation. I think we will go directly to the presentation by Dr. Fang Wei. And then we will have questions after the two presentations. Dr. Fang Wei, please feel free to start and to share your video.
Yes. Sorry, I muted. Well.
So, thank you, Dina. Let me share my screen.
Please. We can see it, but not in.
It's working now.
Fit in presentation.
Is it okay now? Okay.
Thank you.
Good.
So, let's start. Hello, everyone, and welcome to today's webinar. My presentation is titled as On Revealing Behavioral Cascades, Pathways to Second-Order Indirect Economic Impacts of Disasters. Today, we will explore why we need to look beyond the immediate physical damage of disasters and understand the complexity and the behavioral reactions that drive long-term economic impacts. So to set the stage, let's look at the global wave of urbanization. As Professor Mao told us, and you can see from the projection for 2025 population concentration and assets accumulations are accelerating rapidly. So the last data shows that the world's population is estimated between 8.1 to 8.3 billion in total by the end of 2025. And among them, over 45% of people live in cities. When a disaster strikes, the impacts are extensive. Historically, we primarily focus on the human casualties of disasters. These charts illustrate the staggering loss of life from past mega disasters. However, as devastating as the numbers are, they represent only the most visible layer of disaster impacts. Beyond that, we have infrastructure physical damages. These are also often measured by researchers in the past 2 decades. Apart from that, researchers have been paying attention to the disaster damage to social well-being as well as environmental degradations. Apart from this, the indirect economic impacts of disasters, such as what Professor Mao told us before, has been raising more and more awarenesses from both research, academia, and government workers, officers. This is because those micro level changes will pass through industries and regions and time to lead to macro level economic impacts. This is an example of the huge earthquake happened in China in 2008. So, because of these cascading ripple effects, the world's growing annual bill for disasters has skyrocketed. We are no longer look at the $70 to $80 billion a year we saw before the year of 2000. Today, including the direct, indirect, and ecosystem impacts, the total disaster cost exceeds $2.229 trillion annually. Despite knowing that for each dollar spent on disaster risk reduction delivers at least around $15 in terms of averted future disaster recovery cost, only 13% of money are used for pre-disaster prevention. This investment gap is alarming, especially considering the impacts of climate change. The rising global mean temperatures and sea levels have been proved leading to the increase of the severity of these disaster impacts across both natural and human systems. And worth to be noted that these impacts are unevenly distributed. So how do researchers and policymakers estimate these vast indirect economic impacts? So I did a literature review of those methods have been used in this domain. So generally, these methods can be divided into two parts, the non-economic models and economic models. So for the indirect economic impacts illustrated as before, these non-economic models has inherent limitations. They only, for methods like cost survey and cost modeling, they only look into a part of the economic impacts caused by the direct economic losses. Well, for the economic models, these are all macro level economic models. They have advantages in this topic, such as input-output models and computable general equilibrium models are very widely used in this domain. But even though the current research still has limitations, existing research most focus on the disaster-induced business interruptions, which is just what Professor Mao did before. And for the other impacts caused by micro-level agents like individuals, households, these behaviors are not well considered. But for us, like if there is a storm or a heavy rain, we may cancel our trips, have some online orders instead of going to the supermarket in person. All these activities has consequences. So apart from businesses side, for individuals and households like us, disaster-induced property damages or other infrastructure services disruptions will have consequences, such as we might lose our part-time, we might have income decrease, or we have to buy extra things that will spend and take use of our available money and time. All these consequences will be passed to the economic system, because for household like us, is kind of the center of the economic system. On the one side hand, we have provided our labor endowments to producers, and on the other hand, we use our money to buy things, no matter it's basic survival needs like food, medical care, or its social needs like we have to make travels, we have vacations. All these needs will be passed to the economic system. And imagine if there is a disaster that strikes to infrastructure system and their service shutdown will will lead us behaviors to change, and all these changes will be passed and cause cascading effects across the economy. And also worth to be noted that for residents or households like us, we are different. We have different levels of income. We live in different places. We have different disaster experience that might drive us to lead to different, totally different behaviors under disaster situations. All these kinds of impacts are not well considered in current research. So this drives us to start a case study or a case study based research. We consider an earthquake scenario that will lead to severely transportation infrastructure disruptions, and this will affect the behavior of micro level individuals and lead to indirect economic impacts. So this is a multi-disciplinary work conducted by researchers from UCLA that focus on the earthquake hazard analysis, and researchers from USC that works on the transportation infrastructure network modeling. And for me, I'm working on the economic impact assessment using economic models. So this is a preliminary, very early framework that we proposed. We have data inventory, we simulate the earthquake impacts, and have transportation network modeling. After that, they generate the transportation disturbances data. Based on this, I conducted the indirect economic impacts, especially for the secondary order indirect economic impacts caused by this disaster situation based on input-output model. But if you know this model, input-output model has huge inherent limitations, such as linearity, without consideration of price perturbations, and without consideration of micro-level household behaviors. And all these limitations kind of blocked itself for further implementation in this area. So after this, we moved to CG models. So this is a comprehensive estimation of the indirect economic impacts caused by transportation disruptions under disaster situation. So in this, a CG model called the curve model is employed, and for each situation, for like the direct economic impact, physical damages, business interruptions, and secondary indirect economic impacts, we consider the passenger flow disturbances and freight flow disturbances. For each route, we have calculated the initial shocks that initial shocks that be introduced into the economic system. And the results proved that considering households' behavioral changes under disaster situations is important. But this is not enough because CG models also has limitations. CG models itself is a macroeconomic model that's not used in disaster impact estimation. And for disaster situation, it's not that flexible to consider household behavior changes. For example, we have time constraint. Each of us have only 24 hours a day. If we have to spend more time on commuting because infrastructure is shut down, we have to cut our time spending on other activities. And this will have consequences. We might reduce our leisure activity consumptions, or we might have reduced the productivity during work because we are commuting too long time. And so my job is to investigate these kinds of secondary indirect economic impacts by conducting modifications on CG models. And the modification is conducted by introducing the time constraint. For this part, this is a normal part of a standard static CG model. We have households, producers, governments, and all these arrows means their connections, and these connections will be illustrated by equations. And based on that, I introduced this time constraint in this model, and this will allow us, if there is a disaster and infrastructure disruption, we might introduce external shocks to this time constraint and based on this, the impacts, cascading impacts can be simulated by CG models. This model is also being tested based on case study. We have considered an earthquake case study. Earthquake case happened in the Los Angeles County, and this picture is the Greater Los Angeles area, one of the biggest metropolitan area in the world. We consider transportation infrastructure disruptions by truck vehicles and private vehicles, which represents the freight flow disturbances and passenger flow disturbances correspondingly. And the analysis period is set as 1 year. And this is functionality perturbations of transportation systems, and these are the results. So first, we look into the indirect economic impacts of freight flow disturbances. In total, these freight flow disturbances caused by earthquake will cause $3 million GDP losses, and it might lead to the wage slightly goes up because of the supply and demand relationship. Compared with the impacts of freight flow disturbances, the impacts of passenger flow disturbances are huge. In total, it can lead to over $100 million GDP losses. And what's interesting is that because I introduced this time constraint here, it will allow households to change their time distribution among activities. And the results shows that households will tend to cut their leisure time spendings and maintain their work time in order to maintain their income and thus their utility under this situation. This can be seen as the inherent resilience of households' behaviors. And this is only one kind of inherent resilience. For us, actually, we have multiple ways to mitigate the disaster impacts on us. We can adjust our spendings on commodities and services. We can buy insurance in advance to cover the losses if there is a disaster. Or we can do reforest projects to make our home more stable under disaster situations. All these kinds of mitigation measures need to be considered. But if this reminds us, is there any way that we can put guidance on interventions to help these households have better performance under disaster situation and thus leads to mitigate the total indirect economic impacts of disasters? For this, we have to consider the actions from government or other administrative departments. For example, under disaster situation, they will implement a series of disaster mitigation measures, and all these measures will have effects. But when we conducting literature review, we found out that by singly consider their mitigations conducted by governments is not enough, because micro level agents like individuals and households, they can how to say that, they have mutual effects between government actions and households behaviors. Let me give you an example. So for these mitigation measures conducted by administrative departments, they launch the financial subsides, they have codes or warnings, all these kinds of activities will affect individual behaviors. People tend to have higher adoption behaviors or or enhance the perceptions and take proactive response under disaster situation if there is mitigations conducted by administrative departments. And from individuals to administrative departments, residents' complaints will affect government's policy prioritizing our infrastructure repairing orders, and our self-protection behaviors can kind of reduce the rescue burden of these governments. And this picture shows the synergistic evolution of private self-protection behavior and public operation efficiency. But for current research, from the perspective of holistic disaster mitigation, existing research has two general limitations. First, on the practical dimension, the interaction between administrative government's mitigation behaviors and household behaviors, these interactions are not fully captured. This can lead to a situation referred as the safety development paradox. So researchers at the coastal area of Europe found out that in order to mitigate the impacts of disaster, the government will have high standard of protections and reinforce their dam among the coastal area. So instantly, we think this can protect us and alert people to move away from dangerous areas. But the simulation results illustrated that these kinds of government behaviors can, to some extent, reduce public risk perception and lead to population growth in coastal areas. This is called the safe development paradox. And on theoretical dimension, the major limitation lies in the oversimplification of the interaction mechanism between governments and households. For example, we have illustrated the dominant paradigms in this domain and their limitations. All these interaction mechanism simplification will lead to inaccurate estimation of the disaster impacts as well as the efficiency of mitigation behaviors conducted by governments. So this lead us to conducting a new part of research. by integrating agent-based modeling and CG models to simulate the behavioral changes of households under disaster situation, how they interact with other micro-level agents, and the disrupted environment under disasters, as well as the interactions between households and the government. And we are considering using a series of theories and methods to quantify their behavior. And this is still an ongoing work. So if any of you have interested to collaborate on this topic, please contact me after this webinar. And in general, to sum up, so by conducting this aforementioned research, so it illustrated that micro-level agents and their behaviors need to be considered under disaster situation, and attention needs to be paid between their mutual impacts and interactions among the whole societal and technical systems. No matter for short-term behavior shifts or for considering the long-term risk adaptation. And to conducting this, the collaboration between from researchers from different domains needs to be conducted. And that's it. If you have any further questions, please tell me.
Thank you very much, Dr. Fang Wei. We are now opening the mics for questions. There were a number of questions that were addressed to Dr. Juan Mao. He has answered many of them in on screen, so you can read it. But maybe Dr. Juan Mao, would you like to answer them lively as well?
Perhaps Professor Mao is not online now. Perhaps we go to the second question and then
Yes.
Yes, we leave the Abbas question for
later.
Yes, for later. Yes. So there's a question from Zachariah. How quickly can supply networks recover after major disruptions? So I think it's a question for Fang.
Okay. So in my experience, it depends. In China, the supply network disruptions usually can be recovered in a few days and even few hours, depends on the severity of disaster and how effectiveness of how effectiveness of the recovery actions conducted by governments. I think in terms of this, China has advantages. But still, all these kinds of actions are time-consuming, human resources consuming, and expensive. And as we all know, the economic growth is kind of reduced in recent years. So the Chinese government is also trying to find out, is there any way to encourage social organizations and other forces to join in this procedure. So that's it.
Okay, thank you.
Okay,
Well,
thank you very much.
yes, if there are any questions, or you can also raise your hand, so we will allow you to speak and introduce your questions. So, but in the meantime, I have a question for Fang. So I think I have a similar question with Abbas. So I think your model is more granular, so which includes many, if you said macro perspectives. So my question is, who will use the results finally, and if it is any real applications or implementations of such kind of model in any areas. Yeah.
Yeah, I see your point. Because it's indirect economic impacts, it's not that visible and cannot be estimated as the minutes after the disaster happens. So a lot of people ask me, why are you conducting this kind of research and what's the use to conduct this? So my answer is that for the implementation of indirect economic impacts um, estimation in China, we have launched a national standard for the to estimate the indirect economic impacts caused by earthquake in 2012. And for research, for academia or academic researchers like us, the estimation of these kinds of impacts is not the end, is not the only thing we want. By conducting these kinds of estimation, we want to know better. We want to have a holistic view of what are the impacts of disasters and how big it is. In the end, we want to have more accurate insights of how these impacts happens and what are the sensitive regions, what are the sensitive group of people, what can we do to have more efficient mitigation measures. And all of this is based on an accurate, holistic understanding of disaster impacts. And for this, the indirect economic impacts of disasters cannot be ignored.
Okay, thank you. Thank you very much. So it can be regarded as kind of more comprehensive understanding of disaster impact. Yeah. Okay, there's
That is
another question. Yes. A question from Kandaka. Could the total indirect impact, i.e. the first order plus second order, be greater than the direct impact in the long term? Yeah, very interesting question.
Yes, and my answer is absolutely yes. But it's not happens to each of the disaster situation. But a lot of research has proved that the indirect economic impacts can overpass the direct economic impacts. No matter it happens in China, like the earthquake. Uh, the earthquake example I proposed before, the huge earthquake happened in China in 2008. So after a post-disaster estimation, results show that for the mostly damaged county, the GDP losses, it took the county over 10 years to capture the GDP increase before the disaster happens. And for other situations, what I can think of is like huge earthquakes in Japan and the wildfire disaster in the coastal area of American. All these kinds of research focusing on these kinds of natural disasters has also illustrated the indirect economic impacts can sometimes are often bigger than the direct economic impacts. But it's hard to capture also.
Yes. Yes. Thank you. Thank you for answering the question. Yeah,
Thank
please,
you,
Dina.
Dr. Fan. I have a question, and I would like to understand a little bit better how do you link the micro modeling at the level of the household to the macro model to then understand the level of secondary and indirect impact 10 years down the line. Can you give a little bit more details on that and what you have mentioned the CG modeling, but the CG modeling is still a macro model. So how do you go from one to the other? Thank you.
Yes, thank you for your question. You really hit the point. This is a very tricky problem that we are facing. So for both macro level models like agent-based model and micro level economic models, so they are both very complicated. So how to integrate these two kinds of models together to have integrated multidisciplinary research is a tough job. So now we are considering, since we need to understand the mechanism of how household behavior changes under disaster situation. By understanding this theoretical mechanism, we can customize our ABM model or CGE model. And this might reduce our work for model construction and data collecting. So this is the thought we are trying to implement, but still it's a tough job. But
Yes, in engineering, we use like typologies and we use, archetypes to
yes,
just
I see that. Mhm.
clump together things that we think behave more or less in the same way and use aggregate indicators. Is this something that is done in economics?
No, absolutely not. So let me share my screen probably. I need to share my screen. So this is definitely not an economic work. So let me introduce more about this multidisciplinary framework we built before. So the reason why we are introducing or we have collaborations from different departments of other universities is that based on previous literature review, we found out that there is an inconsistency or the researchers from different domain work on themselves. They don't collaborate. For example, for engineering, they use topology models, or they use other network instruments to simulate the functionality perturbations under disasters. But these informations are not effectively passed to economic models. So all this will kind of compromise our work in this domain. And this also motivate us to conduct this multidisciplinary framework and work through deep into these economic models to make modifications and make sure their variables and parameters can be directly linked to engineer models. So this is thoughts.
Thank you very much. I think there is a message, question by Marcial Rivera. We can allow you to talk if you wish to talk. Just open your mic and introduce yourself, Marcial.
Hi, can you hear me?
Yes, we can hear
Yes.
you very well.
Okay. First of all, thank you for the presentation. It's quite very new and good information. I just was wondering about what happened in developing countries where sometimes when a disaster occurs, um, there were losses before. For example, we're measuring that there is a lack of energy, but that lack of energy uh, can exist before the event, the earthquake, the hurricane, on and how does these models can work with uh, the lacks of infrastructures that may exist in many developing countries. That's it. And thank you for the opportunity. Have a good day.
Okay, I see your point, and I also read your questions. So, do you mean the unevenly distribution of disaster impacts between like developed countries and undeveloped countries? But developing countries and developed countries. Yes, and the answer is yes. So in previous slides, I didn't give it that much time, but so a research published in, I think, Nature have shows that the impacts of disasters is unevenly distributed between within regions and countries. So yes, for example, for developed countries, they have more mature insurance system. People can buy insurance to mitigate their loss if there is a disaster. But for developing countries, we have limited resources and not so well developed in the insurance industries, and this will limit our behaviors. For example, in China, the insurance for huge natural disasters is only being promoted like within 6 to 5 years, I think. It's not that well developed as Japan. So this is the truth. But this unevenly distributed impact not only happens between countries, it also happens between group of peoples with different characteristics. For example, for rich families or rich individuals, they have better awarenesses of risks. So they will take actions to reduce the probably economic losses under disasters. They will distribute their money and they always tend to buy insurance in advance. But for poor people or normal people, we only have limited money, and we have to keep ourselves very busy among activities just to make the ends meet. So this will drive us has limited time, limited attention, awarenesses, and limited budgets on these kinds of disaster risk reduction behaviors. And so this can lead to the uneven distribution of disaster indirect economic impacts. And there are also other statistics if you check on it. So this also drives us, or at least motivate us to understand what are the mechanism of human behavior changes under disaster situations. I think this also can answer Dina's previous question.
Thank you very much. Thanks for the answer. And there is another question from Zachariah. So Zachariah, again, if you want to ask your questions, you can open your mic, please. Zachariah? Can you unmute yourself?
No.
So maybe, yes.
Yeah, we just read the question.
Yes.
I can read the question.
Yeah, please.
Please.
So he is asking how this framework or methods can be generalized to other developing countries or situations. So this is also very interesting question. The answer is the model cannot be 100% be generalized. But what we are doing now is trying to build a general framework and offering instructions that can advise or guide peoples to understand what are the general and accurate impacts of disasters and what kinds of methods have huge advantages in this area. After that, we are thinking of to build a general transferable models that can be used in across other regions, situations, levels, severity of disasters too. But in general, I think this will happen soon. And since we are now have better awarenesses of disaster impacts, and we are having rapidly developed in technologies. We have better huge amount of data and techniques to solve this.
Thank you
Thank
very
you.
much for the answer. And
Yes.
unfortunately, Dr. Kwan Mao, are you there?
No, Dr. Mao is now unavailable due to some emergencies, so he's very sorry about it. But he is happy to answer Abba's question by email. So I have seen the email, the Abba's email. So I'm sorry,
Yes.
Abbas. So he will answer your questions very soon by email. Yes.
Okay, and
Uh,
Bas has sent us his email, so yes, we can do that.
Yes.
Okay,
Yes.
that's great. Thank you, Abbas. Then please, a few closing words maybe from you, Zaishan.
Yes, if you don't have any other questions, so maybe we can complete our today's webinar. So thanks again, everybody, especially our speakers, for today's event, and feel sorry again for some technical issues today. So yes, so let's hope to see you at the end of this month. There's another webinar. Okay, so see you. Bye.
Bye-bye, and thank you again, Dr. Wade, for a very entertaining talk, and sorry to hear that Dr.
Thank
Mao
you
has
for
an
having me.
emergency,
Yes, yes.
hopefully nothing too serious. Thank you.
Yeah. Thank you.
Bye-bye.
See you.
Thank you.
Bye.
Bye-bye.
Bye-bye.